All right, I think it's time to get started. Again, welcome to pre-buying components to prevent go-to-market delays. My name is Ryan Saul, and I'm going to be talking through one of the most critical issues that we have here in electronics manufacturing over the last couple of years. It's definitely something that has been affecting every single one of our customers here at Tempo Automation pretty dramatically and consistently. So why is that? Definitely, I would say, as a contract manufacturer doing short runs supporting NPI development for electronics, we've seen a sea change in the fundamental challenges associated with supply chain, with sourcing for critical components particularly. Components just aren't as available for just-in-time purchasing as they used to be. And I think this isn't something that's going to be a surprise to anybody listening, but it has affected our customers' outcomes and our customers' timelines pretty dramatically. And that's what I'm going to be talking about today. The general outline of the problem as we see it and how we would propose that people should be looking at a solution. So first of all, who am I? My name is Ryan Saul. I'm Director of Sales Engineering here at Tempo Automation. I've been at Tempo for 8 years, and we do NPI, prototyping, and small volume runs for electronics assembly and turnkey fabrication and support. It's been exciting, I would say, very much to support a lot of our customers as they go to market with their products. It's one of the best things about working at a contract manufacturer. You get to see a lot of outcomes. You get to be a part of a lot of programs. This is what I'm talking about, or this is one of the critical fundamental things I'm talking about. And I know that anybody who is on this webinar who works in supply chain knows that 34 weeks is not that bad. I mean, that's a seriously upset schedule, but it gets a lot worse. It's unfortunate that some of the components that we require to move forward with product development are now very difficult to get our hands on. Worst case, you go to find a component and it says 99 weeks or non-stocked, contact the manufacturer for lead times. Then it's very difficult to pin down a schedule for that part. I want to talk about more than just the amount of time it might take to get a component in. Let's say you place that order, you're waiting for 34 weeks. That's a delay, absolutely. But there's additional sort of more hidden delays associated with an uncertain supply chain. You're looking at the time it takes for you to find which distributor or manufacturer has the component that is most available for you. There's the shipping associated with getting those components in, particularly if there's a chance that they could get stuck at a port waiting for customs. There's the unfortunate reality associated with potentially redesigning your build around an unavailable or obsolete component. Because if you're looking at 34 weeks plus, it may be more efficient to make some design changes in order to no longer need that unavailable component. And that isn't free, either in time or in money to do that engineering work. And then, of course, if dipping your toes in the gray market, if you're looking for components that are available from brokers, it's very possible that you're going to need to do some additional validation to be confident that those components are acceptable for your build. And again, that takes time. So all these things really stack up. And unfortunately, the amount of time they stack up to is a real question mark. Question marks are almost the worst kind of delay, because that means you don't actually know when you're going to be ready to finish your project. So this is an estimation. Comes from a source down here at the bottom of the slide. Companies lose 33% of after-tax profits if they ship a product 6 months late. This is obviously an average, and the reality is that it could be a lot worse than this. It could be that your product doesn't even launch because you've missed the opportunity. It could be that you lose a significant amount of money because a competitor beats you to market. It's, again, a big question mark. It's difficult, I would say, to put a monetary value on time to market. Of course, it's going to depend on the industry. It's going to depend on the program or product that you're developing. But we've definitely seen customers have relatively apocalyptic consequences for struggling to source their components alongside competition that doesn't have much trouble at all. So it's a very, very serious consequence. And it's not just about irritation and delay. That does translate into dollars for sure. But there's a better way. And I'm not proposing something that is super groundbreaking. I'm proposing something that is a mature and well-trodden path to de-risking this kind of challenging supply chain environment. And the customers that we have that are most successful are doing this. So let's talk about differences in some components before we get down to the specifics of this solution. Everybody knows if you're a design engineer, if you're a supply chain professional, if you're a program manager, some parts are more critical than others. That means that either designing to alternates might be very easy, or sourcing these components might be a little bit less risky. We're talking about commodity components, so resistors, capacitors, inductors in many cases, compared to critical components, active components, specialized custom designed components in many cases. I would say that over the last couple of years, we've seen the envelope of critical components broaden to the point where some relatively basic elements have become more challenging to source. But this is a bit of a custom judgment that you have to make looking at your bill of materials, looking at your risk tolerance, I would say. So what is this solution that I'm talking about? And that is pre-buying your components. That is getting ahead of the need that you know you're going to have in order to de-risk the overall production schedule and to save money. And this is definitely a bit of a counterintuitive solution for some people because they're not ready to go to manufacturing. Maybe their design isn't even completed yet. So why would they purchase the material? And I can tell you, it is just the best way to avoid delays and additional cost overruns in the future. So that's just before you're ready to go to manufacturing, just buy your parts. You're not buying your fabrication. You're not necessarily supplying even the fabrication design or assembly drawing, fab drawing, just the bill of materials. And then you source those components and you warehouse them. You keep them on hand, either at your manufacturer or at your own facility in advance of your need. Now, I know that this is such a direct, almost boneheaded solution that it doesn't bear discussion. But I'm going to talk about why this is more of a high leverage solution than it might sound. Generally speaking, you have an opportunity to source your critical components before the design is finalized. You know, you've gone through your schematic development. You haven't reached layout yet, for example. Is there a chance that your design will change and there might be some alterations in your components? Yes. But I propose that risk is lower than the supply chain risk associated with delaying procurement. That risk is relatively significant. It's a hedge against a bunch of extra work that you might have to do in the future. It's also a guarantee that everything that is available now is available for you when you need it because you already have it on hand. It's also a huge hedge against unforeseen interruptions in the supply chain. So if something takes a much longer time to get through customs or ends up getting delayed by the manufacturer or distributor, that's okay. You are well in advance of your need anyway. And it's also a hedge against gigantic cost fluctuations. I say cost fluctuations because prices can change, but I also mean that very aggressive, almost scalper-like behavior that you see out of brokers who will purchase up thousands, if not the entire stock of critical components and then sell them for 3 times, 10 times the cost. So here's some examples of how you can save money. This is assuming that the prices don't change over time. This is, again, a relatively direct, I would say pretty straight over the plate description of how you can cut costs. If you need 10 parts for an individual build, but you're expecting to need 100 parts over the course of the lifetime of your program, then you can save 30 to 50% easily just by buying the 100 when you need 100. Yes, you have to let go of that money a little bit earlier, instead of holding on to it until the builds actually are required. But you lock in that lower cost that comes with a volume discount. The volume discounts that are available really depend on the component. Sometimes the volume discounts are relatively minor. Sometimes they're really aggressive. Sometimes you're saving nearly 50% of the cost by buying components in the quantities you actually need. We see this be the highest leverage in NPI because the overall volume of components that are going to be needed over the life of the program is very high, but the individual builds might not take that many components. So if you're paying, 80 cents for an individual transistor, then if you could pay 30 cents for that transistor in the future, you would make that choice. It's not even a question of whether or not you'll need more in the future. It's just that you don't need them yet. And so I propose that taking advantage of these volume discounts is a real no-brainer. You know you're going to need the parts, so you can lock in a lower price for the components on your NPI immediately. It's also true, as I said previously, that this is just the price today. It's very likely that in the future you would be happy as a clam to pay 5 times this price just to be able to get your hands on the components that you need. So there's a huge amount of de-risking that you can do by buying at the volumes you know you need. Now, I would say that our customers back in 2018 would have looked at these volume discounts and said, that's true, but there is a significant risk that my needs will change. And I don't want to buy components that I might not need in the future, which is fair. That is a risk. And only you can understand, certainly your contract manufacturer wouldn't have this insight, would know how much risk that really is. But I would say that for the customers that Tempo has had that have been least affected by these pandemic era disruptions in supply chain, they've decided that the risk associated with design change is lower than the risk associated with supply chain disruption, which is to say they know their eyes open that they might make some design changes and that those components that are purchased may not be required anymore. But once your design gets to a certain point, you might have the confidence that the vast majority of the elements of your bill of materials are locked. And thus the risk is relatively minor. And the risk of supply chain disruption, I can tell you, is not minor. All right, so this is an example of project requirements for a manufacturer customer of Tempo's. This is a not uncommon NPI scenario. So we're talking about over 1,000 total prototype/development boards needed. I can tell you this started off with quantity 10 or quantity 20, but over the course of 6 months to a year, they moved through prototyping to engineering and finally production validation before we ended up on a incremental monthly delivery schedule to get them the boards that they needed. The goal was, of course, to move these boards to high volume production, which is not something that Tempo supports. But these boards are always going to be moving into high volume production in a low cost overseas environment. They needed to keep their NPI teams from using production inventory because this was an iteration on a product that was already being produced, and their production inventory was necessary for their production orders. Yet they were relatively comfortable that the core set of critical components were going to remain the same, and they needed to de-risk the availability of those components, which of course is a very common scenario. And it was really important for their development to have the fast turn available for each individual batch during NPI. And that's something that Tempo provides regularly. It's what our customers often come to us for, is those quick turns available for short run orders. I apologize, looks like a bullet point sticking off the bottom here. It just says absolutely critical at the bottom. What they did early was they analyzed their bill of materials to determine the most critical components and the components that were most at risk in the market. They do that using their own supply chain team and using a Tempo supply chain team, which can support them as a contract manufacturer should be able to do. And then immediately pre-buying all of the critical components is one of those things that when we're talking to our most successful customers, they will chuckle to themselves about how horrible it would be if they hadn't done this, because the unforeseen circumstances that come up are going to come up. And if you've already sorted things out in advance, and you feel like a genius. For each build that they did, they drew down the purchased inventory that they had prepared for the purpose of the program. And because of that, they were able to succeed with their product timeline. They ended up expanding their pre-buying to cover all the components, not just the critical components, because they didn't want to have to keep doing the just-in-time purchasing, even if there wasn't risk associated with it. So Tempo, for example, currently holds or held during this program more than 2,500 unique components to support a variety of different customer designs, and about 700,000 units. That's just individual components in stock for this customer's program. Ended up being very successful, and we're very happy to support additional interested parties within that customer because it was so successful. So let's talk about some of the reasons that you might be considering not pre-buying. What are the risks associated with this behavior? I talked about one of them already, which is overbuying. You haven't purchased enough components, or you've purchased too many components and you no longer need them because your project quantities have changed or your design has changed a little bit. And this is a real risk. This is one of the reasons that you can't proceed to pre-buying without BOM analysis, without a significant amount of design time under your belt, without some confidence that you understand the way the program is going to develop on the engineering side. That said, like I previously said, a lot of our customers have decided that the risk of overbuying is a financial one, not a lead time oriented one, which means that they're willing to take that risk in order to de-risk the lead time associated with the program in its entirety. And even the financial side of that risk is lower than the financial risk associated with not going after the components they need aggressively. Underbuying. Yeah, you could absolutely not buy sufficient components. That's definitely a significant risk. Again, you have to analyze what you anticipate the life cycle of NPI to look like for your program. This is associated with attrition. If you're doing a bunch of short runs, a bunch of NPI build cycles, there's going to be an elevated level of attrition relative to a production build. And so you have to target your pre-buying with that attrition in mind and with the overall number of revisions that you plan to make, which is not something that you're going to easily be able to know in advance. So I understand that this can be a difficult target to hit. How can you overcome some of this? I would say definitely working closely with the CM is important. Whether or not you're warehousing your own inventory, if you're taking that on, or you're having a CM do your kitting for you and pulling from inventory that they hold on your behalf, it's important to work with your CM to understand the attrition quantities, the attrition rates associated with the components that you're pre-buying, so that even if you do select the correct number of revisions, if you imagine your NPI process going the way you plan, that you will have successfully purchased the correct number of components. It's also true, and I can say this with a regrettable amount of personal experience, that it's necessary to select the right CM. You don't want to have a CM doing your inventory management that isn't set up to succeed with inventory management. At Tempo, we recently onboarded a really advanced, exciting digital inventory management system, which I'm not going to talk about right now. But I can tell you that before that point, before the pandemic, all of our inventory management was relatively manual, and it was very challenging. The challenging part of it meant that it was risky for our customers. Storing inventory at Tempo before we set ourselves up to succeed with that was not a good idea. It wasn't a service that we offered proactively to our customers, because we knew that it was a high risk behavior to hold parts on our customers' behalf without the right inventory management system. I can tell you it's also true that it's high risk to hold it yourself. If you are holding a large number of components, both unique components and individual components, or inventory volume, I guess would be the way to put it. If you don't have an inventory management system that is set up to succeed there, it's easy to lose track of components or to damage components by accident. So I highly recommend one of the critical adaptations that's necessary. If you're going to pre-buy your components, you need to have an inventory management system in place that's going to help you keep track of what components are where. This is particularly true when you are doing development of a program that requires significant documentation to be associated with each component. This could be data and lock codes, for example. And if you are just keeping them in a drawer, it's really, really easy to lose track of the provenance of those components. So inventory management is super duper critical. It's even worse if you are trying to manage components for multiple projects at once, particularly if those components share some part numbers. You don't want to be cannibalizing one program for another program by accident. And so it's very much necessary to have some sort of better than spreadsheets method of storing your inventory and managing your inventory by product timeline. Super, super important. It's also true to revisit your forecasts. You got to do that because you're going to take your best guess at the level of component inventory that you think is necessary. But the truth is that that's going to change for sure. If you're looking ahead far enough, then the level of certainty you can judge with is only so high. Revisiting those forecasts based on things that go down, maybe you need an extra revision, your thought should be immediately, okay, do I have enough attrition to complete my overall NPI process, given that we are doing an extra revision? If the answer is maybe, then you should definitely make sure you get those components as soon as possible, because you may not be as early as you were. It may not be as good as having predicted the future perfectly, but it's still much better than waiting until you run out and then trying to decide what you're going to do. And then what are you going to do with your extra parts? Definitely, if you are de-risking your project schedule by doing judicious pre-buys, you're going to end up with some excess inventory. Having a strategy for what to do with those components is helpful. So in some cases, you can roll that inventory into your production inventory. If, like in the example I gave, your build is transitioning to a high volume manufacturing after NPI. Perhaps you would keep them on hand for future prototyping, or perhaps you have the opportunity to sell them back to the market. It depends on the component, depends on the scenario, but in general, I'd recommend having a plan for that. How much money are we talking about here? Because this is a financial issue in addition to the lead time risk one. It's difficult to quantify, but you can make some heavy estimations here. And I can tell you that in many cases, the financial side of this is a little bit like being nibbled to death by ducks. That's a famous saying. I don't know who said that initially. Every $20, every $40 you're spending on overnight shipping, every extra 30 cents you're paying for a component, over the NPI cycle of a complicated project, those tiny costs can add up to a budget busting number. We got some one example here that we're gonna share here, but the idea is that it's more than you would think. So we've actually got a calculator on our website where you can put in maybe some details about your project or about your bill of materials or a hypothetical bill of materials and see potentially what the costs associated with that, sort of the delay of purchasing could be. So a single critical component where each part costs $20, you need 2 per board. That's not that many parts, right? If you're only building 10 boards per iteration, then maybe you only need 20 to 25 parts for that iteration. But if you expect 5 iterations before moving to production, potentially 2 days to find the components and place an order, 7 days for the components to arrive once you've purchased them, and $40 to ship each order, then we're expecting that 56 total days would be lost to delaying your procurement, and $785, give or take, would be lost by delaying your procurement. And this is just one BOM line item. It's a relatively minor issue. I would say that this $785, maybe you could say, you know what, I can afford that. That's not so bad. But remember that each bill of materials could have, 100 line items or more. It's very difficult to quantify the cost associated with this amount of lead time. This is potentially catastrophic to your schedule. So I guess when you're making the trade-offs between the risk associated with doing a pre-buy and you're trying to decide whether it's worth the time and effort to go through the relatively rigorous planning that's required to accomplish it responsibly, you should think about the real concrete costs associated with not doing that. That's the whole thing. That's my whole presentation. I guess I would love to answer any questions that we have. I can view your comments live. These could be questions about our experience as a CM working with our customers, about inventory management, about project timelines, or anything else that comes up. I'd be happy to to answer your questions if you submit them. And in general, thank you everybody for attending. All right, we got I got a couple of questions here. So one question we got are what kind of lead times we're seeing on ICs. It's pretty broad. I'll be honest. The question goes, or the answer goes from 0 days. We can expect to see the part tomorrow at 9 a.m. to it's unobtainium. You have to travel to Pandora to retrieve this component. It's definitely a wide open sort of blue sky answer. In reality, it's worth considering whether or not you have a completed design, meaning that if your design is complete, but some critical component is unsourceable, then do you have a completed design, or do you have a hypothetical design that potentially could be made in a different reality where those components were sourceable? So I would say that a big part of design development has got to be the sourceability of those components. And I would encourage all engineers or supply chain program manager types to evaluate the sourceability of the bill of materials before you design yourself into a cul-de-sac. And you end up wasting a bunch of your own engineering resources, because sourceability is just as important as any other element of the design, for sure. Got another question here. So I know that there are a lot of good ways to do inventory management, just as there are a lot of bad ways to do inventory management. The question is, what qualifies, or what do we think is a good inventory management solution? What Tempo uses is a product called Innovax. It's a digital inventory management system that allows us to digitally receive elements of a bill of materials, components, into our inventory management system to the point where they're physically indexed and digitally indexed at the same time. So we know both what components we have and physically where they are without anybody having to write anything down or anybody having to manually record that the event has occurred. Gives us very high confidence that when we go back to Innovax looking for the components, that the correct number of components will be there and where to find them. It also is helpful in our case because Innovax communicates with our SMT system. So as components are consumed, it's able to keep an updated live value of our inventory. So that's helpful. I know that I would say any successful inventory management system would be one that combines the physical and digital identity within your inventory, so that you know what components are where, and that is something that's kept digitally. Anytime you've got a physical drawer with a label on it that somebody wrote with their hand, that's real bad news. I've got another question here. So the question is it sometimes acceptable to purchase components from other manufacturers, other CMs, rather than the OEM? I would say that we do see that happen sometimes when contract manufacturers will have excess inventory of an individual component. That very much falls in the category of component brokers or the gray market. It's risky to do this because there's a chance that traceability could be lost. The only honest answer is it depends. That might sometimes be acceptable. It really depends on your risk tolerance and the specific situation. In some cases, it may be fine, and the only additional negative associated with that behavior would be additional cost. But in many cases, it may be necessary to do additional testing or inspection or vetting on those components to validate that they are the components they claim to be. Overall, you'd want to avoid that if you possibly could. Definitely it's something that I've heard of, that we see happen on rare occasions. All right, everybody. Well, I think that is a wrap. Thank you, everybody who is listening to this point, for joining us. And if you have any follow-up questions, anything that you're looking to get answered about inventory management, about pre-buying components, or about electronics NPI in general, please don't hesitate to reach out to us at Tempo. We'd be happy to chat. You can reach us on our website, tempoautomation.com. Looking forward to seeing you succeed with your programs.